All right, so here is the second part of our functions review, part two. So our objective is to write domain and range with the proper notation, find domain restrictions, and perform basic algebraic function operations. Okay, so let's talk about the notation of the domain and range. There are two types of notation, the set notation and the interval notation. So we're going to learn how to properly write them in both ways. So in set notation, you have these brackets here, and you always use these brackets. Okay, they don't change. For domain, it's always going to be x, and a little bar here is just basically saying x. Your domain is going to be the x's such that x is in the set. And whatever the set is, we're going to write that there. You know, like all real numbers, or x is less than 5, x is larger than 7, whatever. Same thing for y and for range, except that is y is the variable. Okay, so this is the way you write set notation. The brackets don't change. The format does not change. Okay, for interval notation, you use either the parentheses or the squared bracket. Um, and domain, you just put the number from where the interval starts to where the interval finish, and the parentheses is when it does not include the endpoint, and the squared bracket means it does include the endpoint. Okay, and you guys will see in a bit. I guess I should have wrote that down here so you can see, but oh well, too late now. So for example, here, so you have a function here, or yeah, it is a function, but here's a graph, right? And to look for the domain, you imagine that it comes straight down to the x-axis, right? So it comes straight down like this. So where on the x-axis does it cover? It goes from -1 to 5, but it does not really go up to 5, right? It ends right before 5 because that's an open dot. So it goes from -1 all the way up to right under 5. And then over here, it goes from -2 all the way to the negative infinity because there's an arrow there. So let's write domain. Let's write the domain based on that, right? So the domain in set notation is that, so here is that bracket, it does not change, and x and the bar does not change. And then I have x is less than -2 because here x is everything from the left of -2. And then here I have x is larger than or equal to -1. Remember, it's equal to because it's a solid dot, and there's no equal because it's an open dot. Okay, same thing here. X is less than or equal to -2 because that's a solid dot. So if it's open dot, no equal. And we can write that in interval notation. So there are two intervals from -infinity up to -2, and another interval from -1 to 5. So I write it like this. Remember, whenever you're talking about infinity, you cannot get there. It does not include an endpoint. Infinity is not an endpoint that you can get to. So it's a parentheses. Here is a squared bracket around the -2 because it's a solid dot. You do include that endpoint. And this symbol here is union, meaning this and that. Okay. It's just you have this set together with that set. Okay. And there is also a squared bracket here because that's a solid dot, parentheses because that's an open dot. Okay. Let's talk about the range then. Here is the range. So when you talk about range, you want to look to the y-axis here. All right, so here I have the range is at just this point. So range is at 1, and here the range is at from 3 to 6. So in set notation, I have, again, the bracket does not change, format doesn't change, bracket, y, and the bar. It says all the y's such that y is equal to 1, because it's just that, or y is larger than or equal to negative or positive 3. Oh, there should not be an equal here. It should be less than 6 because that's an open dot. That there is a mistake. Okay, should we just be less than 6? In interval notation, I have the range is at 1. You see, I have square bracket because it includes 1, but it goes from 1 to 1. Basically, it's just one single point. And then union, and then square bracket for 3, parentheses for 6. Okay, let's go on to domain restriction. For most functions that we deal with, we're going to assume that the domain is all real numbers for most of them. Okay, there are some of them that we have to figure out the restriction, meaning that the points that are not in there. Okay, so it's everything in the real numbers except for some numbers. And the two types that we're looking at are these. Okay, so the first one is if you have like the root of an expression, and when that root is an even number, like the square root, the fourth root, the sixth root, x has to be larger than or equal to 0, meaning it can't be negative, because you can't do the square root of a negative number. I hope that makes sense to you. Can't do the square root of a negative number, so you have to find a restriction for that. So here, here is the other type where you have the function, the f of x is something over an expression of x. This is when the bottom cannot be equal to 0. So these are the two situations that we have to deal with. So let's look at an example of the first type. You have f of x is equal to the square root of 3x minus 5. Here is the square root of something. So that something cannot be negative. So you take that something and you have to set that to be So you have to set the 3x minus 5 to be larger than or equal to 0, and you solve for what x has to be. So 3x has to be larger than 5 because you add 5 to both sides and then divide by 3. X has to be larger than or equal to 5/3. So that's our domain. Okay, it has to be in there. It can't be in the negatives. So the domain is the set of x such that x is larger than or equal to 5/3. And in interval notation, is just going to be from 5/3, and that is the squared brackets because it includes that because there's an equal, and then it goes to positive infinity because it has to be larger than that. Another example of the other type. So here you have something over an expression. So the bottom cannot be equal to 0, so you set x minus 3 not equal to 0. So x cannot be equal to 3 because you add 3 to both sides. So here, you're going to assume that it's going to be all real numbers except for 3. So the way you write that is, in set notation, is that you just write x such that x is not equal to 3. So anything that is not 3 is part of the domain. And in interval notation, you have to go from negative infinity up to 3, and then parentheses because it does not include 3. And then you start again at 3, goes to positive infinity. So it goes from negative infinity up to 3, and it curved parentheses, meaning it does not include the last point, and then you start again, basically just excluding the 3, and that's how you would write that. All right, so function operation, this is really, this is a lot of stuff, but I'm going to try to do it real quick, and then we can talk about it more in class, okay? So here is the set of rules that we have to follow. If you have addition, you have f plus g of x, which is just basically f of x plus g of x. The domain for that is just the intersection of f of x and g of x. And just the concept of intersection itself, I feel like it's going to take us a while to talk about. Intersection of sets, meaning it's the set that includes all the elements that they both have. Okay, so the intersection of the set from 0 to 10 and the set from 5 to 15 is 5 to 10, because they include, those are the elements that are in both sets. Okay, so think of it that way. On this video, I don't want to spend a lot of time explaining because it will take up a lot of time. If you're confused by that, we'll talk about that in class, okay? It's the same thing for subtraction. The domain is the intersection of the domain of the two functions that you're operating with, except for division. It's the intersection of those two and the one that is being divided by. That one cannot be equal to 0 because it's at the bottom. So we'll do a couple examples here. Here I have f of x is x squared plus 2x. G of x is x squared minus 9. So the domain for f of x is all real number, right? Because there's no restriction there. And domain for g of x is also all real numbers. So I'm going to do f plus g of x. So basically, I have to add these two functions up. So I have x squared plus 2x plus x squared minus 9. Basically gives me 2x squared plus 2x minus 9. And the domain for that is the intersection of this and this. Since they are both all real numbers, their intersection is also all real numbers. So the domain is all real numbers. Let's do another. I'm going to do f over g of x. So basically f of x divided by g of x. So I have x squared plus 2x over x squared minus 9. The domain is the intersection of these two, which is all real numbers, except the bottom cannot be equal to 0. So I'm going to set the bottom equal to 0 or not equal to 0, and I solve for that. So I factor and I get x cannot be equal to 3, x cannot be equal to negative 3. So the domain is going to be all real numbers except for 3 and negative 3, so I can write it this way. The set of x such that x is not 3, x is not negative 3, or in interval notation. So this is set notation, right? Interval notation is negative infinity up to negative 3, union, starting negative 3, up to 3, and then union 3 to positive infinity. So basically you're doing this to exclude the negative 3 and excluding the 3.